everyone, and welcome to this edition of Shergroup on the Sofa. And I'm so excited today because I've been waiting to interview this person for a little while. She's been incredibly busy, but we have managed to get a date on our calendars. So welcome, Faith Hawthorn, today. It's great to meet you. We're going to get into her interview in a moment. Honestly, this is one of the most interesting interviews I think I'll ever do in my life. So I don't want to build her up too much, but when you understand what her chosen topic is, you'll understand why. But before we get into the interview, I'd just like to give a shout out to my #1 fan today for Shergroup on the Sofa and Shergroup. And that's Mr. Ross Saunders, who's in Norwich, England, UK today. So, hey, Ross, hope you're having a great day. I think Faith is going to give you a little shout out.
Yep. Hi there, Ross. I hope you're well.
There you go. All right. Thank you for that. So I know Faith is I actually know her dad, Ian. So we better give Dad a shout out as well. So hey, Ian.
Yeah, hi, Dad.
Hi, Dad. And Ian and I have known one another. He's at HSBC Bank, a senior guy there, and he was extolling the achievements of his daughter on LinkedIn. And because we're buddies, I had a look at Faith and what she was doing, and now I understand why Dad was extolling the virtues of what you do. So come on, tell us, what do you study?
So I study exoplanets. So these are planets that orbit stars that are outside of the solar system. So when you go outside and you look up at the night sky and you see all the stars above you, many of those will actually have planets of their own, like the planets of our solar system. We orbit the sun. These planets will be orbiting those other stars, and they have all kinds of interesting things that happen. There's many different ways in which we find them. It's one of the biggest growing fields currently in astronomy, and I've been lucky enough to be doing my PhD in this for the last around about 3.5 years, and I'm nearly at the end of that process now. And that's sort of my kind of main focus really, is finding planets that are interesting, that are unique, types of planets that we haven't necessarily been able to find before. So kind of lots of different things.
Okay. I just think this is amazing. And of course, your dad was on LinkedIn saying about your achievements.
Yeah.
Exoplanets. What the hell is an exoplanet? And went and had a look. Like, what?
Yep.
It's
Yeah.
mind-boggling, mind-boggling. And I also just mentioned to you before we actually started recording that my dad was a Star Trek fan. I started watching Star Trek when I was about 4 or 5, and Doctor Who. So we've all grown up in our house. We're all big sci-fi fans. I'm just asking you, wasn't I, whether you rate us as credible?
Yeah.
Or whether you think we're nuts.
I think it's sort of one of those things that it's, science fiction is very much a pathway for a lot of people into getting interested in science and in space, especially. I grew up very much watching Doctor Who. That was my,
Right.
that was my thing. Many of the people that I work with, they're also big science fiction fans, and we sort of get excited, when some kind of new science comes out that reminds you of some sci-fi things. For example, you see the planet Tatooine from Star Wars is often sort of brought up when you're talking about kind of binary stars and things like that. So it is actually really useful for us to have those sort of science fiction parallels, so we can actually kind of explain to people what we actually find. It kind of gives them a bit more kind of interesting context. So yeah, we love it.
Okay, I just wanted to clear that out because there's a lot of us out there, because that's a growing movement in itself in terms of people that are interested in science fiction and based on science that is continuing to emerge, which of course you and your scholarly academic kind of community are pushing to us and telling us about that. So I think it's so exciting. So all right, so we have these exoplanets. How the heck do you find an exoplanet?
So there are many different ways, or kind of how you find very different types of exoplanets. So I use 2 techniques in particular. So the one that I mainly use is called the transit method. So you have to kind of imagine that you've got a star and you've got a planet going around it, and as it orbits, it's going to actually block some of the light from that star. And if you keep watching that brightness over time, you're going to see this sort of beautiful little U-shaped dip in your data as you watch the brightness change, and you're actually seeing that planet orbit that little star. And we can actually sort of work out, okay, what's the size of the planet compared to its star? How big is it? And then we actually combine that with sort of knowledge of how the star responds to the planet's gravity. So we know that, for example, the sun exerts its own gravity onto the Earth, hence why we're sort of kept in this circular orbit. We go around it pretty regularly. But also planets, even though they're very, very small, they still exert some gravity back on their stars. And what we actually see is the effect of a star moving forwards and away from us. And that's sort of a measurable effect. And that kind of tells us, okay, that there's something causing this change, causing this movement, but also how big that object might be. There are other ways, so we can actually watch sort of stars kind of passing in front of and behind each other on the sky. And there might be planets that are also kind of affecting those changes. We've also found stars that kind of move across the sky in very particular ways and patterns that might sort of show us that there's like a separate body kind of orbiting and causing a very sort of kind of like a spiral pattern on the sky, if you like. There's sort of kind of derivative methods that from each of these that are maybe not quite so successful. I think it's about 75% of the planets that we've found, which is well over 5,000 now, have actually been found using transits. So it's currently by far the most successful way of actually doing this.
So when you find, when you find a planet, do you find planets with the same sort of chemical composition as Earth? Or are you finding them more like, I don't know, Jupiter and Neptune, gas kind of planets? What do you find from this analysis of these planets?
So we found some really interesting and some really strange cases. We found planets that we don't have in our own solar system. So a lot of what we find are actually planets that are sort of somewhere in between the size of Earth and Neptune. We call them super Earths or mini Neptunes, kind of like take your pick of both. Right. And so we have nothing like this in our own solar system, but they are extremely common. We found, so when the field was sort of starting out, we found a lot of very large planets, so kind of around the size of Jupiter or larger, because they tend to sort of show bigger, more obvious signals in the data that we could quite easily pick out. You can kind of see them by eye. We are sort of starting to push down now to the kind of smaller planets, so your sort of Mercury-sized planets. There's a few of those. Certain sort of techniques are better at doing, different types of planets than others. In terms of the sort of chemicals and things, there have been quite a bit of variation. So nothing quite exactly like what we see on Earth. But we are, sort of looking at kind of individual cases where there might be kind of water in the atmosphere or, kind of something interesting going on, maybe some silicate particles, interesting things like that. So quite a big range of stuff.
Is that what we call a Goldilocks planet when you're finding something similar to Earth or, in that kind of where it could become habitable at some point?
Yeah, so what we call the habitable zone is sometimes called the Goldilocks zone. The story of the three bears. It has to be not too hot, not too cold. It has to be just right. So that's effectively a sort of set of distances from the star where you could have liquid water on the surface of a planet. That's the only requirement for a habitable zone. There's all sorts of types of habitable zones, but that's kind of the one that we sort of mostly think about. But the fact that a planet is in the habitable zone might not mean that it's actually habitable. It might sort of have all these, it might be sort of too close to the star, maybe just a little bit for its kind of atmosphere to not be quite right. But we do know that water, at least on Earth, is really important for life. So that's kind of why we focus in on water as a kind of marker of quasi-habitability, if you like.
Yes. I can imagine. And in terms of what drives your sort of research? Is it institutions on Earth looking for alternative? Is it driven by economics? So that, I don't know, there might be lithium stacked up on a planet, that's not reachable yet, but could be in the future, because lithium is a very important ingredient in lots of things, or gold or platinum, some of the precious metals. Is that the thing that drives your type of research and funds it? Or is it a genuine interest to know about the universe? I can't quite tell.
Yeah, so it is. I think really for us as researchers, it is about the knowledge side of it. Really,
Of course.
it's sort of what can these planets that are outside of our solar system, what can they tell us about our own solar
Yeah.
system? What can they tell
Yeah.
us about the Earth? What can they tell us about how we formed and everything, and how we've kind of changed over time? Like kind of where do we fit in the equation, basically?
Yes. Yes.
But funding is extremely important to what we do. We have all these sort of proposals and stuff. We have to, be able to pay our researchers to do what they do, our PhD students, our postdocs, and also all of the missions that we have, all the instruments that we want to build, all of the programs that we have going, they do require funding for the equipment, for the maintenance costs and everything. So it's a whole big sort of ecosystem that goes on to actually kind of keep astronomy running and flowing as it should.
And what I'd like to think, and you'll tell me if I'm right on this, but although I'm based in the States now, but I'd like to think that the United Kingdom is, is forging ahead in its science community with some of this research. I'm sure we have competition from the States and China and some of those leading economies, but I'd like to think that we, in our Cambridges and Oxbridges and universities that you're connected to, that we are at least a big part of the conversation.
Yeah, we are an absolutely huge part of it. I mean, my university, I'm at the University of Warwick, and we are one of the largest astronomy research groups in the country, possibly even the largest, depending on how you look at the numbers of the others. And we are sort of right at the forefront of especially research in the UK into exoplanets. There are some other institutions that we work very closely with, Leicester, Cambridge and Oxford, that all have their own research groups that are also doing really wonderful work. And we are sort of really at the front of a lot of these kind of large telescopes. There's usually people from UK institutions that are involved in the biggest missions.
Yeah.
Even though they might be sort of officially attached to NASA, we do have a massive stake in them in the UK, which is quite amazing. So all that data and all that work is also, we're also involved with it.
I think that's brilliant, and it's brilliant to hear that. I mean, I see some of the images that I read the Daily Telegraph, but it's and they publish the photos that come back from the Webb telescope. I mean, they're just stunning in terms of this universe where we all have,
I mean, so I remember when those images first came down, we were actually hosting what's called the National Astronomy Meeting, or NAM, at Warwick.
Yeah.
This was I think this was about 2 years ago. I think this was 2022. So we were sort of, fortunate enough to have many UK astronomers at our university, and there was a little session where they were sort of holding a little kind of telecon where they were showing the very first images from Webb, and everyone was sat in this room and they came up and we were just completely stunned. So we were really lucky to sort of have that timing, but it is just amazing what it's doing.
Yeah, and just the clarity of the imagery that's coming back. I mean, it's amazing. And I'm speaking as somebody that, like my husband, we sat and watched the first moonwalk, where it was very, very grainy. So to see this type of stuff coming back is truly amazing. And you're right into it. It's fantastic for you.
Yes.
So how do you find planets that are further away from their stars? I mean, I would imagine that in our solar system, our star is very, it's ever present. We see it every day. It's always there. Is that different in other parts of the universe, and how does that work?
So the main sort of point of this really is that we are very, very good at finding planets that are very, very close to their stars. So if you imagine a single year on Earth is about 365 days. On some of these planets that we found, it's maybe only about 3 days. There's one where it's about 18 hours. That's a whole year. So it's literally orbited the star in 18 hours. We are, which is pretty fast. So we're very, very good at sort of finding these kinds of planets, because they tend to do that transit thing where they pass very, very frequently. You'll sort of see this happen, sort of once every 18 hours, as it might be, or once every 3 days, or once every 20 days.
You're sure it's not a rock? You're sure
yeah.
how do I know?
It is, yeah. Yeah, it's a weird rock, but it is definitely a planet. But yeah, so in the last sort of couple of years, I've been focusing on, okay, how do we find the planets that are actually further out, the ones that are perhaps on kind of the period of Earth around the kind of 365 days or more mark. So I kind of sift through the data in a particular way. I sort of exploit the way in which a particular NASA mission actually collects its data. And we sort of look for cases when you only see a couple of these transit events in quite a long period of time. So you know that your planet has only passed in front of that star twice, perhaps in maybe about 500 or more days.
Right.
And we, as I said, we're sort of using the way in which one of these NASA missions called TESS actually takes its data to actually find those. And we've recently released 85 candidates to the community for them to go and follow up and look at themselves, that are these planets that might be around the kind of periods of more like Earth.
Right. And do you get to name these planets, or do you get your first dibs on naming a planet because you found it?
Yeah, sadly, no.
Oh, I was going to say yes then. I was like...
So all of the planets that we find, most of them will just keep their catalogue numbers because it makes it easier for other people to then go and find them if they want to go and do their own research. Some of them do have names. So every few years, the IAU, which is the International Astronomical Union, will have sort of naming event where they will have a selection of planets and they will invite countries to essentially contribute a name. And often those names are kind of from their own sort of culture and mythology. So yeah, some of them do have names, but that's a very sort of small subset out of the over 5,600 planets that we found. Most of them just have catalogue numbers.
So 5,600 you found. How many do you think there are out there? Have you got any kind of guesstimate or estimate?
Yeah, I mean, these 5,600, they are just the ones that have been confirmed. There are 7,000 more candidates alone from a single test mission, the one that I work on. And this sort of represents the nearest stars to us. We've sort of looked a little bit further out with the Kepler telescope, which was it was about a decade ago now that was up and operating. And again, that sort of looked at a very small field, if you like. It's a very sort of small area of the Milky Way. So I think, there are just many more thousands to be found out there. I can't easily put a number on it. It's very difficult. But even what we've found so far is a tiny subset of what we actually have.
I think we can all appreciate that. It's just so interesting that you're even looking at that tiny number. I mean, who knew that there were people like you that were building a career and expertise around this, subject? Fascinating. So how is the research? I mean, there must be developments in this research as you get better tools and better equipment. And so how is that changing over time? How are research change?
Yeah, so the sort of field of exoplanet discovery as a whole is fairly young compared to most of physics. So the first planets were only discovered in about 1992, 1993. And then the first planet around a star that was like our sun was about 1995. So this is a fairly young area. And in the last sort of 20 years, it's really grown really quickly. We've found all, as I said before, all these sort of interesting planets that, we never expected would be out there. We thought we were fairly normal, but maybe we're not. And it is, I think, one of the fastest growing areas of astronomy. We are every year, getting these better instruments, we're getting these better telescopes, and we're finding out more interesting things. Every week something new and exciting comes out that could, challenge what we already thought. And that's the way it's been for the last 20 years, really.
Yeah.
So we are kind of at a really good point in the research at the moment where we are just growing massively and continuing to grow.
I mean, obviously we all wonder whether there are more different types of species of humanoids in other environments, and there's a continuing conversation and skepticism around that. But obviously, you know, as you find these planets and you find that they have this habitable status, the conditions for life, I guess, that, you know, is increasing with the finding of these planets that can support life, whether it be humanoid or some tiny molecular structure. You know, it's so interesting. I hope we're not alone in the universe.
Yeah, I also certainly do. It'd be a very lonely place otherwise.
Yeah,
I think
exactly.
we're
Yeah.
yeah, I think it's going to be sort of interesting as to how it kind of challenges our own understanding of what life is. You know, we are just one planet out of those 5,600. You know, could there kind of be maybe sort of silicon-based life form somewhere? At the moment, we just don't know.
No.
We are, you know, sort of making strides in the direction of, you know, looking for kind of microbial life and the kind of products of life in the atmospheres of planets that might actually say, okay, well, you know, these particular chemicals can only be produced by life.
Yes.
That's the kind of direction at which a lot of the work is going in at the moment. That's not my personal field, but it's very much sort of goes alongside what I do, which is the initial discovery of these planets.
Yeah. No, I'm sure once you've discovered them, then there's another tranche of work to do, what about the question of life on that planet. So so you've got 5,600 that have been found. What are the most unusual that you've found?
So there are all kinds.
What's your favorite planet?
So I think my favorite is one of the HD planets. I can't remember the number. It's something like 183776 or something like that, 773.
Okay.
It's basically a planet where it rains glass sideways. So this is a planet where you've got sort of these little tiny particles of silicate in the atmosphere, and under the sort of heat and pressure, they essentially condense into tiny bits of glass. And there's also extremely fast winds on the planet, about I think 8,700 kilometers per hour or something, which is just incredibly fast. So, you know, even though this planet could be very, very beautiful, if you were to sort of actually go there, you'd be sort of absolutely whacked by,
you're
you
gonna
know,
be
little
shredded.
bits of glass.
You're gonna be
Yeah,
shredded.
shredded by these bits of glass raining sideways, which is just so intense and insane and crazy. There's, you know, sort of planets that are just made almost entirely of lava. They're just these sort of like lava covered surfaces around these rocks. Planets that are kind of being like stretched and squeezed by their sun's gravity because they're so close, they kind of turn into like a sort of flattened egg shape.
Oh.
There's all sorts of weird and wonderful planets out there that are just nothing like we could imagine here on Earth.
Do can you use AI tools to kind of build visualizations of the planets with these characteristics? I mean, you're talking, you know, about sideways silicon rain, you know, racing around at 8,000 plus kilo, you know, kilo. I can't remember what the word, but you know
Yeah.
what I mean.
Fast.
How do you know that? How do you visualize that?
And so I think in terms of what you said about AI, you know, sort of creating these visualizations, it isn't really something that we've looked at, mostly because we do have artists that will create these impressions of these planets for us.
Right.
We are actually sort of turning towards machine learning a little bit more within astronomy, simply because we have such enormous amounts of data from these telescopes and from these missions. They are constantly streaming down, you know, data for thousands upon thousands of stars every single day. And we just have to have a way to sort of sort through all of that and to actually find what we're looking for. So we are sort of using the kind of AI and machine learning to sort of help us actually find those signals of the planets in the first place, so that we don't have to kind of do the eyeballing work ourselves. So rather than the kind of visualization side, we actually use the AI and machine learning to kind of find the planets in the first place.
It'd be interesting to put that through ChatGPT and see what visualization it starts to give you.
Yeah.
Some of the things you're seeing, which is not going to be
some incredible videos.
incredible video. And of course, we as humans, we are envisioning these types of environments through things like Marvel and Star Wars and, you know, Star Trek. We've already started on that journey of trying to visualize what other landscapes and environments will look like. But I think the interesting thing about what you're saying is that actually that visualization could be pretty it could be so off the scale that we can't even begin to comprehend, sideways rain made out of silicon. I mean, who knew, So even if we develop warp speed and we got to a planet, we ain't going to get off the plane, we're not going to get off the ship, right? We're going to stay
You got to know what's there.
Yeah, exactly right. That's fascinating. Yeah. So, in terms of finding life on another planet, which is like the universe, you must get that asked. I don't know how many times you get asked that a month, but you must get that asked a lot. I mean, have you made it? Have the scientific community made any concrete? I mean, there was some talk about microbial life on Mars, and everyone was getting very excited about that. Do you think in our own solar system or somewhere else that we're going to find something?
Yeah, so I do personally live in hope for our own solar system, really. So in terms of the sort of planets and moons of our own solar system, we are still sort of understanding some of the processes in the past that might have happened on Mars, that might mean that life could have been there at one point and now it's not anymore.
Yeah.
The sort of lakes and riverbeds that mean that water could have once been flowing on the surface, maybe that had sort of microbial life in it. What's also interesting is that we're also turning to look at some of the moons of the gas giants. So places like Europa, Enceladus, Titan, that have all these kind of interesting sort of oceans that live underneath their surfaces. They're kind of big, like liquid water oceans surrounded by really thick crusts of ice. And we think that perhaps, maybe life could have formed sort of on the very beds of these oceans. So I think we are sort of going in the right direction for that. There are some missions that are going up fairly soon. They're going to be specifically looking at these gas giant moons. So we've got JUICE, the Jupiter Icy Moons Explorer, Europa Clipper. So kind of specifically looking at Jupiter's moon Europa. In terms of outside the solar system, so exoplanets, it really is just looking at the chemical compositions. We haven't yet had sort of a concrete detection, but we are, kind of searching for, like I said before, those particular chemicals and gases that can only be produced by life. That's the real holy grail of what we want, because then we know for certain that life is there. But you need a lot of information to actually make that assertion. There's a lot that has to go into that. But we are sort of, going into that. We are kind of inching towards that direction. You think about where we were, 20 years ago with just 1 or 2 planets discovered, and now where we are, it's, what could the next 20 years bring? That's my biggest question.
And especially now that you've got tools like AI that can drive, through the data at a rate of knots, which was incomprehensible 10 years ago. I know we've had computers for a long time, but even so, that the machine learning is, I guess, a revolution in your world to help you break down the data and make even more sense of it. I mean, do you?
Yeah, absolutely.
Do you get excited about our own solar system in terms of exploration, or are you totally focused on the exoplanet world beyond our solar system, Milky Way? What do you say about that?
So, I mean, I personally am very interested in both kind of our own solar system and the wider exoplanet population as well. Kind of what can one tell us about the other?
Right.
When I was doing my sort of bachelor's degree, my original project was actually looking at Neptune's moon Triton, kind of in the context of these sort of giant kind of solar system gas giant moons. So that's kind of something that is still, close to my heart, is something I very much enjoy doing, and then kind of branched out towards exoplanets. But I think it is all very much connected. We have to kind of use the information that we get from knowing what we know about the solar system, the own planets that we have, to kind of contextualize the exoplanets and vice versa. So they are sort of very much both kind of interlinked. And we are just kind of constantly being challenged on our own assumptions about the solar system and kind of how Earth came to be, which is really exciting.
Yeah. Big Bang and all of that. What my question, I'm going to ask you a question in a minute, but my question is this: what was there before Big Bang?
That's that's kind of something everyone would love to know, I think.
Yeah, it's just like some big black void, and suddenly something kicked off and all these chemicals spilled out, of which the composition of us was part of that,
Yeah. I mean, this is sort of would be more of a question for someone who's a cosmologist, because that's sort of quite a different branch to what I do. So there's sort of the astrophysics, which is the kind of, my sort of experimental stuff, kind of working out, what currently exists right now. And then, the guys who are the cosmologists, they kind of look at the bigger picture of the universe and how it works, and how it is expanding since the Big Bang, and kind of going backwards in time to look at, okay, what actually happened after the big, right after the Big Bang. So we are sort of, working together to kind of look at the whole picture of the universe and the things that live within it. So the kind of contribution of both, can't really be understated. It is very important to work together.
Tiny we are. Tiny.
Yes. Yeah. Well, when you think we are just one single planet out of at least 5,600 and many thousands more that we're going to find, it really does humble you.
I'm sure that's a very and to be able to move through this this content and actually understand it and make sense of it, I think is what a fantastic career you've got ahead of you, Faith. I just think it's amazing that you're into this, and the science, it's not science fiction. This is pure science at a bleeding edge. What are some of the open questions that you think have still got to be answered? I mean, obviously life somewhere else, but what else do you think?
So we are still sort of trying to understand the larger population of planets. So we have, with those sort of 5,600 that we found, you can kind of start to look at, okay, what kind of types of planets are out there? How can we group them together? Is there anything weird going on? We've kind of found that we don't have that many sort of Neptune-sized planets close to their host stars. It's called the Neptune desert. It just seems as though their atmospheres are kind of being stripped away, and we don't see anything like that in the solar system. So it's kind of, where do these sort of strange populations come from? Why do we see certain types of planets more than others? Sort of how is the field going to kind of adapt to the vast amounts of data that we have? There's kind of a bottleneck in terms of getting the data where you see the stars sort of, going backwards and forwards. That's quite difficult to get. There are not that many instruments that are capable of doing it. So we need to sort of, okay, how do we kind of scale up the whole of the astronomy data collection to be able to handle that? And just the sort of wider questions really about where does the solar system fit into all of this? Why do we have these sort of smaller planets like Neptune and Uranus kind of past the gas giants? That seems to be quite unusual. That's quite rare that we find that.
Okay.
A lot of sort of theories kind of still up in the air about how planets form and how they evolve and how they also move throughout their systems. They kind of migrate in certain ways, either towards or further away from their stars. So there's still a lot left to be understood, really, which is quite exciting. It means I've got, a job for I've got things to do.
You've got longevity in your subject, I think.
Yeah, for sure.
I don't think you're going to run out of things to do. And what does the future? I mean, I'm so pleased to hear that the UK has, is using its science community to be a big part of the conversation on this, because it affects all humans. I mean, that's why I'm so interested in it. I think it affects everybody on our planet, and I think sometimes we forget that we are just tiny in comparison to the bigger the whole picture, which is
yeah. It always sort of puts me in mind of the photograph called the pale blue dot,
right,
where you sort of see just the tiny speck of the Earth, from so many thousands of miles away, and that kind of puts a lot of things into context for me, I think, when I remember.
I think you're absolutely right. I think you're absolutely right, just to put it that way, to be honest.
Yeah. And I think our future as a research field is looking extremely bright. We are constantly kind of innovating, pushing the research field forward. Like I said, every week something new and exciting comes out, kind of new data methods and new and interesting planets, and all these brilliant new instruments that are currently being developed. Webb's still doing incredible work for us and still finding lots of interesting new things.
Yes.
And we have big plans for the future. There will be a successor at some point to Webb that will be even better. And kind of that's quite a sort of, yeah, like I said, quite a bright future, I think, for us, which is really, really exciting.
Oh yeah, I mean it's amazing. Well, what about kind of the technology to move between planets and warp factor, and is that just is that science fiction that's never going to get off the ground, or cold fusion? Do you see some of these things coming into space to be able to power spacecraft to move between huge distances?
So I think really it's something that only time will tell. I think there are sort of mathematical limitations to things like warp speed that you do have to kind of be mindful of. It isn't necessarily something that we're ever going to achieve, simply because the maths behind it just doesn't allow for that.
Yeah.
But I think in terms of sort of new technologies and stuff, I think the future is endless, and I think there could just be such amazing things that we can't even dream of right now. You think about 100 years ago, what did it look like then? And you just couldn't even picture the kinds of technologies and the kinds of things that we have right now. So you think, okay, another 100 years into the future, I would love to be cryogenically frozen and come back and see what it looks like.
No, I watch some when I'm watching, I mean, on Netflix and some of the other shows on TV, things like Foundation and Three Body Problem. They're the imagination of humans to think up, what it does look like out in the universe. I think sometimes some of those things will come to pass.
I think as scientists, I think we do often kind of underestimate the importance of creative thinking. This is something that I've been sort of very interested in, is okay, how do we kind of break out of that box a little bit? How do we kind of use sort of creative solutions to some of the problems that we have? Kind of how do we sort of expand our imagination a little bit? And I think we really kind of do need to keep our finger on the pulse in terms of creating these new solutions and these new technologies. So I think having a good imagination, I think, is really important to what.
Well, I think you're right, and I think there are humans like Elon Musk, who I know comes in for a lot of stick, but I mean, here in Florida, I saw another flight go off yesterday. Goes up, and he's building. He's starting the colonization of Mars, and I think that is fascinating. And to have rovers up there and drones up there and flying around, and just like you would on Earth, so I know what
flying a little helicopter on Mars,
I just think is, like you say, 10 years ago, who knew that was even going to be possible? And I just think from these planets in our own solar system, they give us the launch pad to break out of the solar system. But that's just me being a sci-fi geek and not a scientist like you. But I first
both, so
wow, first of all, I want to thank you. I want to thank you for sharing your insight today. I am a complete amateur and a novice, just an interested person. But to hear you talk about this as a branch of science, and to know that it's coming from the UK, I think is fabulous. And thank you so much for coming on our little show and talking about it, and explaining what you do and making it so easy to understand. Honestly, your language is fantastic. Not trying to blow us.
We have to be good at that,
with molecules and all that science stuff I did at school. It's brilliant, and I think for anyone watching this, people at school, you make it very relatable. And that's what it needs to get more people involved and more people interested. So congratulations on your success so far. And I just look forward to hearing more from you. So keep your LinkedIn channel going, and
I will do.
sharing and so you have your own website. Just tell me what that is. Do you know?
So you can just Google my name, Faith Hawthorn, and you'll find my webpage through the University of Warwick, and that's got all of my previous research, all the stuff I've done over time while I've been doing my PhD and beforehand, all the sort of research I've been involved in, all the papers that we've done, all of the info's on there, my press releases, etc. So yeah, that's probably the best place to find me.
And forgive me, are you now Dr. Faith Hawthorn?
Not quite yet. On the 5th of June, I will be.
On the 5th of June,
providing that I pass.
Oh, that's fantastic. And so and you've also, so you've got, so yes, to Google you and then connect with you that way. And then also through the Royal Astronomical Society or Warwick University. I've got a couple of websites, so I'll put those in the show notes so that anyone that wants to reach out. And of course, you're on LinkedIn as well, which is very cool that you're so accessible.
Any questions and things you want to ask about my research, I'm always happy to get emails and messages from people who want to know.
I'm sure there will be people perhaps listening to this who are in education and are looking for topics for young people to pick up on. And this is so relevant because it's all packaged around, and you won't mind me saying this, but things like Star Wars and Marvel and Star Trek, this is sort of in context of that, and it all makes it very relatable for children to be able to understand what is happening in the universe. I think it's fantastic. I wish you'd been around when I was at school. I might have found something a bit more interesting. I don't think it was that. I wasn't that great at science, but I did like all the universe. So thank you so much, Faith. And again, if you find any interesting discoveries and you want to come back on the show and share that with us, we'd love to hear more from you. So thank you so much.
Thank you very much.
Well, and I look forward to hearing and seeing on LinkedIn about you becoming Dr. Faith Hawthorn. I'm sure Ian will be sharing that with his network. Congratulations. So for everyone else, who knew? I'm a big sci-fi geek. I'm married to a sci-fi geek. I have a son who is totally into it. He works at Star Wars in Disney. I have a daughter that's totally into it. So we're a big sci-fi family. And so we completely relate to what Faith is doing, not in a scientific way, just big fans. So it's just nice to have somebody with a completely fresh perspective on life on Earth and where that fits in across the universe, which I think we all need to be reminded of that from time to time, if I'm very honest. So this is us signing off today. Our website is shergroup.com, and you'll find this interview will be posted on our YouTube page on Shergroup TV, along with all the other interviews where I interview interesting people that I meet on my journey. That's why I wanted to interview Faith today, because amazing careers, interesting journeys, which is what it's all about. If you're going to be at work, let's have an interesting job and an interesting career ahead of you. So thank you so much, Faith. And you can find Shergroup on all the channels: Facebook, Instagram, TikTok, YouTube. We're out there, you know it. So please join our community. We've got a lot of interests in our company, and we're not afraid to share them and come out and say what we support. And we definitely support this type of initiative. Why wouldn't we? But we wanted to share it with you, our viewers. So thank you so much, Faith. Really enjoyed talking to you today. Thanks a lot.
It's been a pleasure.
Thank you.